Hello everyone, welcome to another video on our YouTube channel. Today we are going to be looking at differential calculus. So join me as we explore the rate of change that shapes our universe. If you are new to this channel, kindly hit the subscribe button and don't forget to like the video, and make sure once you have watched, you also share to others so that they can also benefit from whatever you are going to benefit from this video, because the video is really enriched. I am Tembu48 presenting this script. You can get to me on WhatsApp using the number on the screen, as you can see there. This is my WhatsApp number. So as we present this lesson, this is part 1 of the lesson. So as we present the lesson, make sure you are following alongside with a book, because this course will carry you throughout life as a student, especially if you are going in for an engineering field. Know that you will never do any interpretation of whatever you will be doing there without knowing calculus. Like, it will disturb you a lot. So grab the concepts now and understand everything as we roll. So this is part 1 of differential calculus. This lesson is produced with the assumption that you have an idea of limits, because that's differential calculus, the initials, right? But now I want to explore differential calculus in details. I believe you have done limits in the lower seats for some students from 5 additional mathematics. So let's get started with the first presentation. So we have right here we have the definition of differential calculus, and it is defined as an area of mathematics concerned with the rates at which things change. That is exactly what it is. So for instance, if you have let's say the speed we know is defined as what? The rate at which the distance traveled changes with time for a particular car. Okay, so for instance, let's say if you want to write it mathematically, you will have speed is equals to what? Change in distance over change in time. So it is a rate of at which distance is changing in time, that is the speed. So this is a rate. Okay, and most of the time when they talk of rate, we are referring to how something is changing in time. Most at times in this particular context, when we mention the word rate, know that we are talking about change of something with respect to time in this particular context. In another context, it might be with respect to something else. So this is the preliminaries. Take note of it. So if a car at the point A moves and arrives at a certain point B, as you can see here, and within this short duration of time, it has covered a certain distance, we will call it delta x. That's how you read it. This is a single quantity, delta x. So this is what the displacement of this car from the initial point. This is the total distance this car has traveled in a very short period of time. That's why it's denoted delta x. Delta x is a small increment, a small change in distance. in this particular case. So if you want to rewrite the expression for speed, so it will be this change, this distance change in what? A small change in time. When the time change, they can move from here to here at a certain time, delta t. It covers a small distance, delta x. This delta x and delta t are what? Small changes or small increments. Those are other names for the same expression. So you can use any one, but take note of it. The speed is expressed as the ratio of what? Delta x on delta t. This is just a ratio, right? It is a rate, distance change with respect to time. That is differential calculus. It is an area of maths concerned with what? The rate at which things change. So take note of it. If you never knew it, keep it like that. Now let's look at this. The speed of a car traveling on the road is usually measured using a speedometer. This is a speedometer here. You mostly find it in vehicles. So that's the instrument you use to measure the speed of a car. Moving to the next slide, we have the gradient of a line and that of a curve. Like I said, these are preliminaries. If you don't know the foundation of any topic, you can never understand that topic, no matter how hard you try. Okay, when you talk of the gradient of a line, we know the gradient of a line is always a constant, right? A straight line has a constant gradient or slope. So the gradient of a straight line is always a constant. Those are the characteristics. Know them now. I had to do a recap of all of this so that you should not be lost when we start the topic proper. So that's the first characteristic of a straight line. And a straight line has a general form of the equation y equals what? Mx plus c, where this y is the function, right? Yes, the function value. Y x is there. This y is known as what? The dependent variable. X is the independent variable. Why we call y a dependent variable? Because to get a particular value of y, we need a particular value of x, right? In this equation. So x is known as the independent. X does not depend on any variable in this equation. It's known as the independent variable, while y is a dependent variable. And in this general form of the equation of a straight line, m is called the gradient or the slope. Okay, we are going to look at that because this is what we will use to derive the different expressions that we'll be using in differential calculus. Now, c is known as a y-intercept. When you draw a straight line, for instance, this is a straight line, you can see where the line cuts the y-axis. It is called the y-intercept, and it's usually denoted in the general form as c. Now, the gradient of a straight line can be found either from the equation of the line, as you can see. So if you have a straight line and you have written it in the form y equals to mx plus c, directly you can read off the gradient, which is the coefficient of x, only when y has been made the subject. Take notes, because most students will make mistakes. Maybe you might have minus y here and equals to say 2x plus c, or let's say plus 5 for instance, and you come and say the gradient is 2. It will be wrong. You have to make sure this y is left alone, not attached to anything. So why should we make the subject of the formula before you can read off the gradient? We can also get the gradient of a straight line by calculating between 2 points, okay, on the line. So let's say for instance we have 2 points x1, y1, that's the coordinate of the first point, and the second point x2, y2, which is the coordinate of the second point on this straight line. If you want to look for the gradient of this line, we'll have to evaluate the change in y over the change in x. So the change in y over the change in x defines the gradient of the straight line or the slope. That's another name. So get familiar with these terms. The names, get familiar with them. It's very, very important. Great tool. Okay, so now looking at the next this thing, you can see the change in y over the change in x. When we talk of change in y over change in x, we simply means the difference between the y values. As you can see, we have been taking y2 minus y1, that's a change in y, and then x2 minus x1, that's a change in x. So the difference between the y values defines change in y, while the difference between the x values defines change in x. Another student might consider the first value minus the second one for the change in y, and do the same thing, change in x as what? x1 minus x2. It is very correct, okay? But make sure, if you start with this first point as your starting value, make sure you will respect it at the denominator as well. So change in y, y1 minus y2 is also correct, as you can see, because here normally if you multiply the numerator by -1 and also multiply the denominator by -1, it does not change the expression, right? So this one will now become -y2 plus y1, so that's y1 minus y2. You will get this, and then down here if you multiply by -1, you will get -x2 plus x1, and that is the same as what? x1 minus x2. Okay, now looking at a curve, to get the gradient of a curve, you have to know that a curve, the gradient of a curve is not constant. It is changing as you move along the curve. Okay, it is always changing. And the best way to evaluate the gradient of a curve graphically is by what? Drawing a tangent line at a particular point. So if you want to get a gradient at a point, you have to draw a line, a tangent line to that point, at that point. And then now from that line, you can read off two coordinates as we did, because a tangent line, as you have seen here, is a line that touches the curve at only one point. A tangent to a curve at a point is a line, a straight line that touches the curve at only one point. Okay, at only one point. No matter how you extend it, it will touch only at one point. You have to note that. So the gradient of a line, or let's say a curve, this is our curve, y equals to f of x at any point on the curve is defined as what? The gradient of the tangent, right? The gradient of the tangent to the curve at that point. So that's graphically, that's how you can estimate the gradient of a curve. And this is the same concept we are going to use to guide the different expressions of differential calculus. That is why we are having this recap. If not, we would have just gone straight into the presentation proper. Like I said, if you don't get yourself familiar with all these things, it will be difficult for you to understand. If you understand now, everything will be easy ahead. Okay, so by definition, A tangent to a continuous curve at any point is just a line that touches it at one point. Like I said, no matter how you extend the line, it will touch a curve at that point, only at that point. So that's defining the gradient of the curve at that point. So looking forward to what is next, we have, let's derive now. Let's look at the derived function or the differential coefficients. Okay, yes, you have to know them. So this is a general approach to the rate of change, and it is this approach you will use throughout the course. So make sure you understand it from now. I think this is the beginning of the lesson. So let's consider our frame. Okay, I've not indicated the axis, but they are there with they have been graduated, right? Yes. So let's say we have a curve. This is our curve, right? Our curve is there, and then now we have a point somewhere on the curve there, a point P. Then now, from this point, we decide to travel a small distance horizontally. Remember, when you are traveling horizontal distance like this, what is changing? The values of x, right? As you are going like this, the values of x are changing, right? From this point, the x value at this point is at point P. The x coordinate is x. So now, let's say we travel a small distance, delta x, indicated by this. From here we travel like this, right? So that's a small change. We have moved a small distance, delta x, from the point P. So it means that the x coordinate initially was here. So if this is a change, the distance from here to here, so it means that this new point here will be what? X plus this delta x now, because we started here, we started at x. That's the starting point. So the new coordinate of x at this point, at this point, this x coordinate, any point that we read from this x coordinate, that will be the x coordinate of any point on this line will be what? X plus delta x. So if we also decide now to travel vertically a certain small distance, delta y, these are small changes, okay? Just small, very minute. I've decided to enlarge the graph so that you will have a better view of it. If not, you will not be able to see clearly. So but know that there are small changes. Don't mind how big is it on the graph. So from here to here, we have decided to travel horizontally like this, delta x, and move slightly upward, and we arrive at this point in the curve. After traveling a distance delta y, as you can see, okay, we now arrive at a certain point Q. So what are the coordinates of Q? Let's see how we got them. Make sure you understand it. From here, look at it. From this point P, we have the x coordinate now. Then at this same point here, this is now x. From here, at this point, it is x plus delta x, because we have traveled horizontally a horizontal distance, delta x from x. So from here is x plus delta x. We are adding, right? Remember, when you are moving to the right, you are adding. When you are moving to the left, you are subtracting on the xy plane. So since we are moving from point x, right, we are started at abscissa x. We now arrive at a new abscissa. This new abscissa is what? X plus a small change, the small addition we have added, the small distance is delta x. This is it. This is the x coordinate of the new point. Then now, the y coordinate. Remember, from distance, vertical distances are representing the y coordinates, right? So the height of this point from this horizontal line, the height is representing the y coordinate, while the horizontal displacement are the abscissas. Okay, So we have from here to here is y, from this line going upward, the height of that point is y. So now, so it means that all these points like this is a straight line now. It means that from here to here is also y. And we have decided now to travel upward. Remember, on the xy plane, when you are traveling upward, is also addition. We have decided to travel a small distance, delta y, upward, as you can see. So that's why we have y plus delta y as a new coordinate of curve. Okay, we have arrived here now after traveling this from where we are waiting y. There was y here now, y there at delta y there. You have this point. Good. That's how you interpret it. Imagine now that we join these two lines with a chord. Okay, we want to look for what? The gradient of this chord. So looking at this, you have to know that this is what? It is read as delta x, like I have already said that, right? So delta x, make sure you know it. This is delta x. There are other notations that you can use. The triangle method, right, is still delta x, but this is the one we'll use in this particular script. This is delta x, and it is a single symbol. Take note, many students misuse it as multiplication. You will see they'll say it's delta x, delta times x when they are doing calculation. It's wrong. This is a symbol, right? It's a small increment. So it is what often called an increment or a what? A change in x. It's a change in x or an increment in x. A small change, small increment to be precise. So now, when you look at this chord, remember a chord is a line that connects 2 points on a curve, right? A line segment that connects 2 points on the curve. So the gradient of this straight line, I hope you are online. The gradient of this straight line is what? Change in y or change. Remember, it's a straight line, so it's change in y or change in x. So you see why we were reviewing that concept of gradient, right? So make sure you get it. It is change in y or change in x. Like I said, this is, somebody might consider this first point P as x1, y1, and this point Q as x2, y2. While another person might consider it as, if you consider it like that, and they want to evaluate your gradient, like I say, you can use y2 minus y1 divided by x2 minus x1. It doesn't matter, or you use y1 minus y2 divided by x1 minus x2. It will give you exactly the same answer. So looking at this, let's use the first one. Y, this is my y2, right? This is my point 2. This is my point 1. So this is y2, this y plus delta y, minus my y1, which is just this y. As you can see, this is just a general point on the curve, okay, divided by change in x. So it's x2. My x2 is what? X plus delta x. Sorry, it is delta x here, sorry. So you try to correct it. This is delta x plus delta x. I made a mistake while typing. So down here, minus my x1. This is my x1 now. Minus this x. This is it. So now y minus y is 0 now. So I left with delta y. And then now x minus s is 0. Like I said, this is x, not y. So this is what? You're left with delta x. So this is how they denote. You see how we have derived the notation of the gradient of this chord, right? So this expression you are seeing here is in fact, this is the heart of everything we'll be doing. Okay. So this is a change in y or a change in x. So this is the rate of change of y with respect to x. That's how you can read it. Okay. So looking at the next slide, we have the fact that if we have our curve, right, y is equals to f of x, that's our equation. You can denote it by y or f of x. It means the same thing, right? So what this means is when you write a function like this, it simply means that y is a y is a dependent variable and this x is the independent variable. This is showing that y is a function of x when it is written like this. Take note, y is a function of x. Okay, so it means that in general, for any particular value of x we input here, we will get the y value of this function. That's the meaning. So if I input x, I should be able to get f of x. Okay, so in place of that point x where I had point p where I had p of xy. So if I input x, my y value should be what? F of x. That's the meaning. So this is my y value, I'll replace it. Then now coming here, we see if I input x plus delta x, I should be able to get what? F of x plus delta x as my y value. So that's why we replace it, the y value of this point Q by what? F of x plus delta x. So take note of this meaning. So this is the y value when x is inputted. So this is the y value when x is replaced by what? X plus delta x. So that's the input. The output is y now and is denoted by f of that point, the function value at that point, in other words. So as you can see, you have this value. This is our delta x. Like I said, you can make it small to your likeness. The smaller this value, the smaller the value of delta y. Okay, so if delta x is small, you can go back to the graph and visualize it. If delta x is small, if like this function, like I said, if you input a small value here inside this function, right, you should be able to get a small value. Okay, so the small output, because if I input delta x, I should be able to get the corresponding output, which is delta y. That's the meaning. So if delta x is small, then the value of delta y will also be small, and this will make what point our final point closer to the point Q. That's point Q will be closer to the point P. That's the meaning. Now this ratio, right? This ratio, delta y on delta x, as it approaches a finite limit. Okay, this one will approach a finite limit when delta x gets smaller and approaches 0. When they say approaches 0, it can be 0.00000. You can imagine that, but it is never 0. It's just that the value is so small that you can consider it to be 0, but it is never equal to 0. So if delta x, our small increment, is so small that it approaches 0, then the limit, this our delta y on delta x will approach what? A finite limit. And this limit is what we call the gradient of the tangent at the point P, which is the gradient of our curve. Like I said, the gradient of the curve is evaluated at a point, unlike the gradient of a straight line, which is evaluated at 2 points. Okay, so and this our gradient, as delta x gets smaller and smaller, is what is known as the derivative or the differential coefficient. So it is denoted by delta y on delta x. So by definition, delta y on delta x, like I said, is a limit as delta x tends to 0. As it approaches 0, delta y on delta x, this ratio will approach a finite value, and that finite value is what? The gradient of our curve, which is denoted by dy on dx. That's why it is red. Okay, so if you replace this by its function, change in y over change in x, remember a change in y was what? Our new y value was what? At the point Q was f of x plus delta x. Want to look for a general expression how we evaluate when two quantities are changing as y change, x changing, not linearly, okay? So as x changes from x to delta x, so the y value will change from f of x to what? F of x plus delta x. This is my final value of y, and this is my initial value. Divide by what? The final value of x is f plus delta x, as we said. That was those were the coordinates of point P. That's why I said that while you're following this lesson, make sure you go along with a book so that you will be copying down the notes. I intentionally put the notes there. If not, I would have just done a normal presentation, and if I inserted the notes there so that you can be able to copy and follow up as we move along. But if you don't get any part, feel free to rewind the video and get it before going ahead. So this is my final value, change in y or change in x. This point is clear. y2 minus y1, x2 minus x1. Okay, the limits as this delta x gets to 0, that final value is what we call the gradient of the tangent. Okay, so following up, if we simplify this, the numerator remains the same, and the denominator x minus x is 0, right? So you are left with what? Delta x. This formula, make sure you know it, is what we will call differentiation from first principle. Okay, this symbol is read as what? Dy on dx. It can also be replaced by y prime or f prime of x. Remember, we say y is equals to f of x. So you can also use dy. This is how it's read, dy by dx. So if whatever is here, it will be d that quantity over d this one and its denominator. This one at the numerator is known as what? The dependent variable, while the one at the denominator is the independent variable. So make sure when you are doing differentiation, there is always one quantity that's a single variable function. There's always one quantity which is considered the dependent one, while the other one is the independent. And the one that is dependent will always be at the numerator, while the one that is independent will be at the denominator. So at the end of the day, these are the different notations that you have. If you have a function y equals f of x, you can have dy on dx, f prime of x, and y. This f prime of x is the same as dy on dx, like I said. You can also write it as y prime, okay? As not indicated here, but we'll use it ahead. So this function that are seen here, dy on dx, is called the derivative of y with respect to x. Derivative. And it's also known as the derived function or the differential coefficient of y with respect to x. Make sure you get it. If not, you will face problems ahead. So when finding the derivative of a function by evaluating its limits, this is called differentiation from first principle. And this is the starting point. Okay, make sure you get it. This is the starting point of differentiation from first principle. And I'll show you a smart way of getting it. And we'll use this formula that you are seeing here, dy on dx equals to this, which is finally equals to this. This is a simplified form of it. Okay, we're going to see how to apply it subsequently. This quantity dy and dx, they are what? They are known as differentials. Okay, we'll look at this in the higher lessons ahead. As a pure beginner, I will not want to get you involved in that. If not, you just get confused and say the course is difficult. So we'll look at the differentials ahead if we have the time. Now, looking at some definitions, we are rounding up with the recap of what you will be using. This is like the foundation. These are the materials that you will use. Make sure you grab them. So we are looking at what? The differentiability at a point. If a function f is defined on an open interval containing a certain real number a, okay, then the derivative of f at that point will be written as f prime of a. You are differentiating at a point. So instead of writing f prime of x, you write f prime of a because your x is equals to a. Okay, so in the formula that you had above, instead of writing f prime of x, you write f prime of a. Replace anywhere you see x, you just put a. But don't go and make a mistake, put delta a. I am warning you guys again. This delta a x is a symbol. It's not a variable here. Okay, it's not a variable quantity. It's a single symbol. It's not like delta of x or delta times x. That's why you see me when I'm replacing, I just replace the only x in the expression, leaving out delta. Okay, provided this limit exists, this is what we call differentiability at the point x equals a. We'll see this in subsequent questions. So just take the notes down as we are going. So now when we look at the function f prime of a, f prime of a will exist when we say it exists, it means that we are saying that the function f is differentiable at a, okay, and f prime of a is the slope of the tangent to the curve at the point a f of a. Okay, remember our x is this. So if x, the input value is x equals a, then the output should be what? F of a, because y is equals to f of x. So replace x by a, you have what? Y equals f of a. So this is why you have this point. Understand it? So the gradient f prime of a is the slope of the tangent line that is drawn to the curve f at this point. That's a geometric interpretation in words. Like I said, I just want to give you all the material we'll be using. In subsequent slides of this same video ahead, few steps not too far from now, we'll see the different techniques and how these things are applied. That's what I'm giving you, so that when we reach here, we'll just use them. I don't want to start using something that you have not seen or you don't even have an idea. Going ahead, we'll have differentiability on an open interval. Well, that was differentiability at a point in an open interval. That's at a particular point inside an open interval. Now, let's look at differentiability on a general open interval. So when we see that a function f is differentiable on an open interval ab, okay, we say that a function f is differentiable on an open interval ab if and only if it is differentiable at every point in this interval. C is a general point. So any point that I pick within this open interval, right? Any point that I pick inside this open interval, if the function is differentiable at that point, then we'll say that it is differentiable. The function is differentiable on this open interval. We will see application of this. That's what I'm giving you. Take down the notes first. Then now, when we talk of differentiability now in a closed interval, there are conditions that must be followed. The function is differentiable on a closed interval a, b if it is differentiable on the open interval a, b. That's the first condition, and also this limit exists. So the limits as delta x tends to 0 from the right. When we take 0 positive, it means 0 from the right. Something greater than 0 but not far from 0. That's the meaning. Okay. So this is a right derivative. And you should note here that this derivative, it is evaluated at the lower bound of this open interval. Are you seeing that? Or closed interval, sorry. You can see that clearly. The right derivative. Take note of it. If you interchange it, you get different results and you have the wrong interpretation. While the left hand derivative, that's the limit as delta x approaches 0 from the left, that's the meaning. When you say 0 minus, it means 0, your delta x is approaching 0 from the left, because anything less than 0 is to the left. So you can have something negative 0 point something, okay, that's to the left of 0. Anything to the left of 0 is negative, but not very far from what? 0. Yes, so that's the meaning. And this limit is evaluated at what? At the upper bound, okay, of our open interval, the closed interval. So if these two limits exist and the function is differentiable inside this open interval, at any point inside this open interval, we conclude that it is differentiable on the closed interval. So that's what you need to know concerning that. So now, what are the steps? Remember, we said differentiation by evaluating the limits of the gradient function is known as what? Differentiation from first principle, right? So when you evaluate the gradient of the curve and take the limits as delta x approaches 0, we are talking about differentiation from first principle. If you are taking down the notes, make sure you highlight those points. So these are the steps that you will be using to differentiate from first principle. If you cannot remember the formula, that's f prime of x equals to the limit as delta x tends to 0 of the ratio delta y on delta x, okay, which we say is equals to the limit as delta x tends to 0 of f of x plus delta x minus f of x divided by x plus delta x minus x. I think that's what we said, right? Or divided by delta x, because that simplifies to delta x. So if you have to differentiate from first principle, you just need to follow these 3 steps. You evaluate the difference, this difference, f of x plus delta x minus f of x. Then now, the answer you get from step 1, you divide it by delta x to obtain the gradient of the chord. Okay, the gradient of the chord. Remember, the chord was a line joining P, Q, those 2 points on the curve. So you obtain the gradient of the chord when you divide. Then the last step is just to evaluate, take a limit as delta x tends to 0 or approaches 0, okay, of this gradient. Don't worry if you don't understand now, we are getting started. Okay, now we will look at the first very example. We have seen all the necessary literature that you need. That was just a recap. Let's get into business now. So remember, don't forget to subscribe, because if you don't subscribe, it will not encourage me to continue creating this content. So make sure you subscribe and share the video to others. The very first question we are going to look at as our first example is a basic question. This question is the most basic question in differential calculus that you will ever meet. Okay, we are asked to differentiate y equals to x squared. This is always the starting point. Yes, for beginners. We are asked to differentiate y equals to x squared. We are differentiating with respect to x, right? The first step we say we evaluate the difference. Okay, now we evaluate this difference now. F of x plus delta x minus f of x. That's what we said. So now all you need to do here is this. This f of x plus delta x means, remember, this function is the same as this y equals to x squared is the same as f of x equals to x squared. So this simply means that I come to this my function here, as you are seeing. I replace x by what? X plus delta x. That's the meaning. So doing that, I'm going to have x plus delta x, all that squared. I'm replacing only x minus f of x. What is f of x? It's a function that was given to you. Okay, I've just replaced. There is nothing new there. So now we have to record this identity. That's the sum of two squares is the same as what? How do you evaluate it? You take the first term, you square it, keep this strict, and you never forget it. And then plus, you take the second term, you square it, plus 2 times their product. Okay, the only way you can master it is by practice. So the first term squared plus the second term squared plus 2 times their product will give you the sum of two squares. So we're going to apply it here, and doing that, we are going to have what? X squared. You take the first term square, you have x squared, plus the second term squared. Delta x is a single symbol, so you square it, as you can see. Okay, this is delta x all squared. It is not like, don't mind the way it is displayed. It is not like delta and then x squared. No, it is delta x all squared. Take note of the notation. Plus what? 2 times their product. If you forget this part, the answer is incomplete. So 2 times what? Their product. 2 times what? X times delta x. X times delta x. Then minus this term. I have seen here. This is exactly the term here. So all you need to do now is to simplify x squared minus x squared is 0. So you are left with this part. As you can see, this part now, this is what you are left with. So if you go further to simplify, you will see that this is what we have. Okay, now the next step was saying that we should divide this answer, this ratio, by delta x, right? So f of x plus delta x minus f of x divided by delta x will now give us this, our answer that we had here. This is it now. X, that's delta x squared plus 2x times delta x. Then we divide it by this delta x. This denominator is remaining unchanged. So I've just done a replacement. And notice that on the numerator, delta x is common. We have delta x here, we also have delta x here, but it is squared here. So we factorize it. So we factor out delta x, we'll be left with delta x plus 2x divided by what? This denominator, delta x. And you can see clearly that the delta x will cancel out, and you'll be left with what? Delta x plus 2x. So now the last step is for us to look for the derivative, the differential coefficient of y with respect to x, which is defined as a limit of the change in y over the change in x. Remember, this expression here was a change in y over change in x, as we said earlier. It will always be like that. So all we need to do now is just take this our answer, this ratio, this change in y over change in x, which is this now. We come and replace it in the same position. So that will be limit as delta x tends to 0 of this answer, which is this. You put it there. Then as delta x approaches 0, so you replace delta x by 0. We are saying that it is so small, delta x is so small that you can consider it to be 0, but it is never 0. Okay, theoretically it can never be 0. So we are just assuming it that it is already 0, but it is not actually 0. It can be maybe say 1.5 0 point something 0000, even 1 million zero, even if you have 1 at the end, it is not 0, okay? Yes, but it is approaching 0. So you just replace delta x now by what? By 0, and you will have 2x. So the differential coefficient of y with respect to x, given that y is equal to x squared, is equal to 2x. This is the first one. If you understand this one, let's move to the next. But if you don't understand, make sure you can also highlight it in the comment section if you need further explanation on any part. Going further, let's look at the second example. Same approach, same everything, yes. So we will see the first thing was in step 1, we say we evaluate the difference f of x plus delta x minus f of x. So same way, I come to this my function and I replace x by what? X plus delta x. That's f of x plus delta x. That's the function value. So it will be what? 2 into, remember, we are replacing only in where we see x. So it is x, 2 into x plus delta x, all that squared plus 3. Okay, because 3 is just a constant, we leave it like that. Then now minus f of x. F of x is 2x squared plus 3. So we replace it there. Then now we open up the same thing that we did here. We expand using the same identity, the so-called identity, right? So you will see this is x plus delta x all squared. This is a sum of 2 squares. I will say we square the first term plus the second term square, then plus 2 times their product. So keep that statement in your head, memorize it. Same statement. So we have to just apply it now. So when you apply it, you have this 2 is outside the bracket. You have to put a big bracket because this 2 is multiplying all of this result. Many students make a mistake and just come and write 2x squared, then plus this remaining part, then plus 3. You have already failed when you do that, and you will not even have the answer. You'll be traumatized while solving. So all you need to know now is that you have to expand as we did earlier. Okay, you have this now, plus 3, then minus this part, you have to distribute a negative sign. Another mistake people make, if you don't put a parenthesis, you might just say minus 2x squared plus 3, which is wrong. So you have to distribute a negative sign to all the terms inside the bracket. So you have negative, this negative 1, this is like negative 1 outside. So negative 1 times 2x squared, that's negative 2x squared. Then negative 1 times positive 3 is minus 3. Okay, then the next step now I have to distribute this 2. So that will be 2x squared plus 2 delta x all squared plus 4x delta x, then 2 times, I think that's alright, because this 2 is affecting only the terms inside this bracket, not the 3. So plus 3, then minus the term as we distributed the thing here, right? Minus 2x squared minus 3. So when you explain, when you go again to explain, to simplify further, we say we evaluate in step 2, this step 1 that was done. Step 2, we say we take out the ratio of this answer. We divide it, you take this answer and divide by delta x. That's the next step, always. So I have to copy everything as you have seen there. Remember here that 2x squared is cancelling out. 3 is also cancelling out because 2x squared minus 2x squared is 0. 3 minus 0, 3 minus 3 is 0. So you are left with this part. That's why you just have it here. Okay. Then I divide by what? Delta x. Same way, delta x is common. Okay. So delta x is common, as you can see. If you factorize out the delta x, you have 2 into delta x plus 4x divided by delta x, which will just cancel out, and you'll be left with what? 2 delta x plus 4x, which is this part. And we're again now to evaluate our limit as usual. Okay, we go and evaluate the limit of this ratio. I emphasize this ratio is delta y on delta x, so don't get confused. it is even preferable to write it as delta y on delta x, so that you don't get confused. So all you need to do now is just to replace delta y on delta x by the expression you are seeing here. Okay, by this expression, you have it there. From here now, as delta x tends to 0, you replace delta x by 0. So that will be 2 into, we have 2 into 0 plus 4x, and 2 times 0 is 0. So you just have 4x as the answer. So the derivative of this y with respect to x is 4x. From first principle, this is what we are doing from first principle. Okay. Now, what about this function? This is a third example, the third classical example that you will find in many textbooks. How do we differentiate this from first principle? Don't run, it is not difficult. Okay, same approach. Evaluate the difference of this f of x plus delta x minus f of x. So all you need to do now is to replace x. Anywhere you see x, you replace it by x plus delta x. That's the meaning. So you replace now, come to the denominator of this fraction and put it there. Then minus f of x. F of x is all of this function. All. You copy exactly what you have there. If you have more terms, addition and subtraction, you make sure you indicate in parentheses so that the negative sign should affect all the terms there. If not, you will be wrong. Okay. All you need to do now is to simplify this fraction, right? This is subtraction of two fractions. And the best way to do it is you take this term here, multiply by the other one here, and cross multiply. This time this is x. Maintain the sign minus. Then this denominator here times this one here is x plus delta x divided by the product of their denominator, right? That's how you do subtraction of two fractions with different denominators. So, or if you wish, this is the LCM. The product of the denominator is always the LCM of two fractions. You can use it as the LCM and you should get the same result. So if it considers the LCM, you will take this divided by this, you will be left with x times this, you have this. Then minus this divided by this, your x will cancel out, you will be left with x plus delta x. That's what you have there now. Then now, if you simplify, x can go, right? The negative side will turn this positive delta x now to minus delta x, and you will end up having this following result, delta x minus delta x divided by x plus delta x. Okay. Then now, finally, the next step, step 2, is now to divide this answer we have by what? Delta x. It's good that you recall that delta x is the same as delta x over 1, because anything divided by 1 is that same thing, right? So we are going to apply what? Division of two fractions here. So when you are dividing two fractions, you can simply multiply the first fraction by the reciprocal of the second fraction. Or in primary school, you used to say you keep the first fraction unchanged, then change its division sign to multiplication, and then you invert the other fraction. That's why I say multiply the first fraction by the reciprocal of the second fraction. The reciprocal of the second fraction is this one now. You just swap it. Reciprocal means 1 over that fraction. When you take 1 over that, it will be 1 delta x. You just swap. The numerator becomes the denominator. That's the meaning of reciprocal. So our delta x cancels out, and you are left with minus 1 divided by delta, that's x plus delta x, as you can see there. Then finally, we are going to have to evaluate this, our same ratio as usual. Our ratio, delta x, that's delta y on delta x. Okay, we evaluate that ratio now, that limit, sorry. So copy this answer that I have. This is the answer that I have here. You replace in the formula, as you can see. Then as delta x tends to 0, you replace it by 0. Okay, that will give you minus 1 over what? Because this is now 0 now, you replace here by 0. delta x alone is tending to 0. It's not x that is tending to 0, delta x. You replace delta x by 0. Take note. You are left now with x times x. Okay, x times x is x squared now. So the derivative of y equals 1 over x is the same as what? Minus 1 over x squared. Good. Now, we have seen the basics of differentiation from first principle. Just to follow those 3 steps and you not get lost. So if you have followed up, please try this exercise in the comment section. Tell me your answer in the comment section. And if you cannot do it, you can get to me on WhatsApp using the number on the screen that you saw from the beginning of the video. So I would like you to differentiate this from first principle. F of x equals 3x squared minus 5x plus 2. Do it from first principle and get back to me on WhatsApp or in the comment section. I prefer WhatsApp so that we'll interact more. Okay? That's the first exercise I'm giving you. Because if you understood what we did, follow the same 3 steps and you get the same result. I'm giving this lesson. After this lesson like this, you have a lot of questions to solve. Yes, because mathematics is all about doing calculation. Okay? But the literature is very important. It's the literature that gives you the understanding, not the solving. If you are solving without understanding, it means that you are just wasting your time. Yes. You need to be able to explain what you are doing to some other person to show that you know what you are doing. So now, I would like now to look at techniques, different techniques that can use to differentiate function. We have seen the differentiation for first principle. There are some functions that you cannot directly differentiate from first principle, and we'll see a lot of them ahead. So with that, we have to explore techniques. Okay, techniques that we'll be using during differentiation. And the very first technique is a power rule. If you have a function y equals to x raised to the power n, okay, to differentiate this function, like I said, the dy on dx is also denoted by y prime. Okay, dy on dx is y prime. To differentiate this function, you copy the power, as you can see, is n. Copy the power is n. You copy it now. Then now you reduce the power of the function by 1. Copy it in front of the function and reduce the power by 1. As you can see, the power is n. N is any real number. You copy it in front of the function and then reduce the power now by 1. That is all. For instance, the first example where we have y equals to x squared, where we went through a long procedure from first principle before we got the answer. So if you are doing it directly from this rule, our function y equals to x squared, then our y prime will be equals to what? I simply copy the power, which is 2, then I reduce the power now by 1. Copy the power in front of the function. The power is 2. I copy it in front of the function, then reduce it now by 1. And that will give me what? 2. This is a 2. X, copy the x. Now 2 minus 1 is 1. So when the power of a variable is 1, don't write it. It's understood that it is 1. Okay? Good. So you see we got the same result now following this rule. So as a second example, if you have y equals to x cubed, then we want to do the differential of this function from first principle. How do we do that? We have to differentiate from first principle. Using this rule, From first principle, normally, you will still get the same result, okay? Using the rule, I copy my power, identify the power first. The power is of x, we are differentiating. Look at the expression very well and master it. This is y equals to our variable, our independent variable raised to some real number. Okay? If it's a real number raised to our variable, you don't apply it, don't even try. So we have y equals to what? X cubed. My power is 3. So I copy the power in front of the function, as you can see, 3x in front of it now. then reduce it by the power now by 1. So it will be 3 minus 1. So that will give me 3x what? 3 minus 1 is 2. So you have 3x squared. That's the answer, and it ends there. So if you can do this directly, you must not write down 3 minus 1. Okay, I'm just doing this for you to understand. So as a simple a smart student, you don't need to be writing this all the time. Just go straight to the point. What's the derivative of this? I know that I'm copying the power. I also have to be as the answer. I will use the power of this term. Reduce the power by 1, so 3 will drop to 2 now. You just write x squared and you are good to go. Next example, if you have this expression, okay, we have to recall from indices that when we have a raised to the power this, or if you have this form, you can replace it by what? The same a raised to the power the negative. The power becomes negative when it goes up, or when it goes down. When the negative power goes down, it becomes positive. So now the power is down. So when it goes up, it becomes negative from the law of indices. Okay. Then now it means that we'll have y prime. As you can see, my power is what? Minus 5. I copy the power minus 5 and reduce it by 1. Okay, so it'll be what? Minus 5 times x raised to the power minus 5 minus 1. That will give me minus 5 times x raised to the power minus 6. Because minus 1 minus 5 minus 1 is the same like adding two negative numbers. Okay, it will become more negative, so it's minus 6. So and then now, following the same rule that we have here, this thing, as you are seeing here like this, is normally supposed to be what? You can rewrite it as 1 over what? X raised to the power 6. When the power goes down, when this term goes down, the power changes sign from negative to positive. That's why you have this term. This 1 over this times this minus 5. So minus 5 times 1 is just a minus 5. And that's the answer. You end there and you're good to go. So you see how simple it is. This is the first technique. Take note of it. Okay. We'll now look at our second technique. The second technique now is differentiation of a constant. C is a real number. A constant means it's not changing. It does not depend on any variable. It's just a real number. So when you are differentiating a constant, the answer is automatically 0. You just write 0. Don't explain anything to anybody. So when y is equal to 4, for instance, 4 is a constant, then it means that the derivative of y with respect to x is 0. There is no x there now, so it's a constant, so it will be 0. Whether the number is so large as what, so long as it is a constant, then the derivative will be what? 0. Also, e raised to the power pi, this is a Euler number, it's 2 point something, 2.7, you know the rest of the digits, right? Then pi is a constant, 3.14, blah blah blah. Okay, so a constant raised to another constant is a constant. So once y is equal to a constant, the derivative is what? 0. That's the second technique. Okay, the derivative is 0. So if I have, for instance, y equals to 2 on 7, whether it's a fraction or it's a real number, so long as it's a real number, okay, and it is a constant, the derivative is what? 0. Take note of this. So once you know this, it will help you to differentiate some polynomial function. You just know that the derivative of that constant part is 0. You don't consider it. So the next technique we are going to look at is the derivative of this function. Remember, we have seen the derivative of y equals to x raised to the power n, where we copy the power and reduce in front of the function and reduce it by 1. Okay. Now we are going to look at the same function now, which is being multiplied by a constant. C is a constant. Okay, it is any real number. It can be pi, it can be root 3, it can be anything there. It can be -1, can even be anything there. Okay, but it cannot be 0, because if it is 0, okay, so we are supposed to say excluding 0, because if it is 0, then this is a constant. This will now be 0 now. And anyway, we are talking of non-zero functions here. Don't bother about that. So now, to differentiate this nature of functions, all I need to do is to keep the c as it is. Don't touch it. Just leave it like that and focus only on this part, x raised to the power n, which we say we copy it, the power, which is n, and reduce it by the power by 1. Okay? The function, copy the power in front of the function and reduce it by 1. Keep the c untouched, the constant. Example, if you say we have y equals to this, so my 5 is a constant in front of x raised to the power 3. So I'll keep the 5 untouched like that and differentiate, use this s cubed. So I'll copy the 3 and reduce the power of 3 by 1. Okay? So now, when you simplify this, you have what? 3x squared. You have it here now. Then 5 times 3 is equals to what? 3x squared now. So that will be 15x squared. Good. From there now, you should notice that this c and this n are being multiplied. Another smart move to take is that once you have it like this, okay, just multiply this power and this constant as you are seeing as a coefficient. So 5 times 2 is 10. Okay, just like we had 3 times 5 15. Then I reduce the power of 5 by 1. I'm sorry, this thing was supposed to be 3 here. 4. It's a typing error, so make sure you correct it. So this is 10x to the power of 4. It's a typing error. Make sure you correct it and don't copy it. Good. Now let's look at the different technique. Another technique now. Assuming you have group of functions, want to use now the rules that we have learned, the 3 rules. Differential of x to the power n, differential of what? C times s to the power n, then differential of a constant. We say when we differentiate this type of function, we copy the power and reduce the power by 1, so it becomes s raised to the power 6. You should note that when you have multiple functions added together, right, you differentiate them individually, treat them as individual parts. So now 2x to the power of 2, this part, to differentiate it, I will simply do what? I multiply like we said now. So 2 is a constant in front of the function. We multiply the power and the constant. Okay, so that will be what? 2 times 4. 2 times 2 is 4, right? Then now we reduce the power by 1. Instead of having 2 now, will be what? 1. So you don't write the 1, you just leave it like that. Then now, same here, this is x times 5. This same x is equals to what? S raised to the power 1, like we said now. So the power is 1. So 1 times 5 is 5. Then I reduce the power by 1. So it becomes 1 minus 1 is 0. Okay? So we have x raised to the power 0 attached to this. But we know from indices that any number raised to the power 0 is 1. So 1 times 5 is 5. 26 is a constant. So the derivative of 26 is equal to what? 0. That's why we don't write it. So this is the final answer. So you see how easy it is. You can also apply that technique here because the coefficient of this term, x to the power 7, is 1. So it will be 7 times 1, which is 7. Then we reduce the power by 6. By 1 becomes 6. So now understand this now. In general, function like this, for instance this type, if you have y is equal to a constant times the independent variable, okay, if you have it like this, so So like a constant times x, for instance, x is the independent variable. To differentiate this function, forget about the x, just delete it and write a constant. Like what we did here. You see that it ended up with just a constant in front of it now. Yes. So take note of this rule. This is another rule that you have to take note. Remember, these are the preliminaries, the basic rules. The next video, I will go deeper into differentiation of trigonometric function, quotient rule, chain rule. You will see all of that, and that's where the thing becomes even more confusing if you don't understand this one, because we will just be applying it. I will not go into details explaining again. So now, like I have always said, if you are new, don't forget to subscribe and also share this video as you watch it. Don't be selfish with knowledge, share it to your friends, let them also benefit. You are not paying for it, okay? Now let's consider another technique. We have been seeing cases where y is equals to something x. What if our function, right, is not dependent on x? So this is a general rule you have to consider. So if you have a function y equals to what? A function that depends on some variable that we don't yet know, okay? And it can be anything here. It can be remember, variables are in algebra, we represent variables with letter. So it must not be x, it can be anything here. So to do that, to differentiate, we'll be differentiating y with respect to that variable that we will see here. That's why I wrote dy on d, that variable. So if it is t here, you will put t dt, dy on dt. So you are differentiating y with respect to the variable that you find here. And that will also be denoted. Instead of writing f prime of x, in general, if it is not x, you write f prime of that variable. If it is t, you write f prime of t. If it is s, you write f prime of s. So which is denoting dy and ds. Okay? Yes. So now let's go ahead to look at an example. Let's say y is a function of t. We write it like this. To evaluate the derivative of this function, we write dy on dt, because what? Our variable here, our independent variable is t. So it's dy on dt, or f prime of t. We are differentiating f with respect to t. Because you can also have what? Instead of, this is just a function, f of t is a function, t is the independent variable, while f of t is a dependent variable, which you have called y. Get used to this notation, don't get confused, because when we'll be doing application of differentiation, if you have understood this, then it will just be an easy move. So in other words, if I have s equals to f of t, s is depending on the values of t, right? For whatever value of t I input here, it will give a particular value of s. So depending on the value of t I input, I will get a particular value of s. So s is an independent variable. S is a dependent variable, while t is an independent variable. Okay? Which variable is depending on who? S is depending on t. That's why we say so. So identifying it, like we said, this y is always the dependent variable. Why? The variable that we'll have here is the independent one. So that will be ds. Instead of writing dy on dx all the time, or dy on dt, you can also have ds on dt. So you are differentiating s with respect to this variable that you have here. Take note of these notations, they are very important. Because students are very funny. You will give a student a function y equals to maybe say 5t squared, and I ask you to differentiate by writing dy on dx. Where is the s coming from? T is a variable, the independent variable, so you should write instead dy on dt. So take note of it, very important. And this is things when you write that in paper 2, you'll just cross it, even though the answer you will get at the end is correct. you can escape that from MCQ. But do the right thing, because even from the university students are doing that error. It's because you have poor understanding of the concept. So make sure you grab it and take note of it. And the only way you can master this is by solving constantly. Okay, it's not magic. Work consistently. When you try the first time it does not go, try again and keep trying. Now going for the next segment of the techniques, we'll have an example. Find the volume. That's the volume of the sphere now. Okay, we have to find the gradient of the function. This is v, and this is v equals to 4 on 3 pi r cubed. We have to find the gradient of this function when r is 2. This is the volume of a sphere. Okay, recall it. It's important that you should be able to recall things. V here is depending on the values of r. So we are looking for the v on the r, because v is a dependent variable while r is the independent variable. The dependent variable always comes at the numerator, while the independent variable comes at the denominator. So you see how we're applying it. We are not writing the y on the s all the time. No, it depends on the function that is given to you. Our function is v equals to 4 on 3 pi r cubed. So it means that the derivative of v with respect to the independent variable r, as you can see, will be equals to what? 4 on 3 pi is a constant. We'll keep it as we said. And we differentiate r cubed, v with respect to r cubed. So now, the same techniques apply, okay? The same techniques. I copy the power and then I reduce it by 1. So it becomes 3r squared. Very simple like that. Then now the 3's can cancel out and I have 4 times pi times what? R cubed. That will give me what? 4 pi r squared. Sorry, 4 pi r squared, yes. So you can see clearly that this is the area. This is 4 times the area of a circle. Okay? Yes, 4 times the area of a circle. We are going to look at the interpretation of this result in subsequent video. This 4 times the area of a circle. You know that pi raised to square is the area of a circle. So we are asked to evaluate this at the point r equals to 2. All we need to do, now that we have the derived function, we replace r by 2. That's the meaning. We replace r by 2. So it becomes 4 pi times what? 2 other square, because r is 2. Then 4 square is 4. 4 times 4 is 16. 16 times pi is 16 pi, which is the answer, right? So when you do that, you have your marks. So you see the application, right? Very, very important to note. So as we move ahead, don't forget to subscribe. And now let's look at some techniques in differentiation. This is a general rule for power functions, and I'll end this video with power functions so that the next one I will take up the others now in short section. The reason why this video is long is because I'm introducing it. The next one we'll be doing the tutorials. Yes, short concept, one example, exercise, just like that till the end. But even though with that it will extend the video to some length. So the general rule of the power functions, if you have generally a function of this nature, right, that's some function that's raised to a particular power n, any real number. Okay, to differentiate it, I will do the normal power rule that I know. I copy the power, very important. I copy the power and reduce it by 1. Good, we stop there. But you are not yet done. This function here, you have to differentiate it inside that parenthesis, right? You have to differentiate it. The reason why we were not differentiating x was just because when you differentiate x with respect to x is equals to 1. That's why we were not considering it. Now, but this is a general rule, okay? You reduce the power by n, you copy the power and reduce it by 1. That's the general form. Then multiplying it now, the answer you get, you multiply it by the derivative of the inside function. This is an application of the chain rule. We'll see subsequently, but we just have to use it now, okay? But differentiate this and multiply. So let's look at an example to this part. We see example. Find the gradient of the function v equals to what? 1 plus 2x squared all raised to the power 6. You see that inside this bracket we don't have x. We have 1 plus 2x squared all raised to the power 6. So this function inside this bracket is not just x. Then you will say that the derivative is 1 and you don't consider it. So apply the power rule again. I copy the power 6. As you can see, I copy it here. Then I reduce it now by 1. The same function, the way I see it, copy everything. You reduce the power now by 1. 6 minus 1 is 5. That's the new power of the function. But that you don't know, you have to multiply by the derivative of this inside function. Where you differentiate 1 is a constant, it gives you 0 according to the constant rule of differentiation, right? Plus, where you differentiate this 1, we say we just multiply the powers now, the power and the constant in front of it. So 2 times 2 is 4, then we will reduce now the power of x by 1. So it becomes 2 minus 1, which is what? 4x. So that's it. As you can see, we have come to the end of this video. When you simplify this now, you have what? 4 times 6 is 24, not 20. So it's just a typing error. So you have 24x into 1 plus 2x squared raised to the power of 5. So I've come to the end of this presentation, and I will leave you guys with some assignments. Okay, the first assignment says you differentiate these functions from first principle. Mind you, the only way you can master it is by practice. Okay, it's by practice. So this is the first one. You try it and submit either in the comment section your answers or through WhatsApp using the number on the screen. The second assignment is you are given that P of E is equal to 100. Find the P on TV. So you see why I was reviewing that concept, that if the function is not between x and y, it is something else, what do? You go back to that section of the video, rewatch it and get the concept there, and you apply it to this question. Then question 3, you have to find the values of x which makes dy on dx 0. Okay, so I ask you to differentiate this function. Okay, then now you find the value of x that will make it to 0, or you just equate to 0 and solve for x. I've given you a guide, make sure you do it correctly. That's 3 questions for question 3. Then question 4, we ask to find what? The value of x for which the gradient of this curve is 6. I will not review this one, you have to use your reasoning. We have been discussing about gradient. Okay, at what value is the gradient of this function 6? When they say the gradient of a function, they are asking you to differentiate. Okay, from there now you can equate the value to 6 and then you go ahead. You make sure you do it and submit on WhatsApp. Now 5, differentiate with respect to x the following functions. I want you to apply the techniques that I gave you. Okay, the techniques that we have just seen. Make sure if you don't understand, go and review. Watch the video again several times and get the concept wherever you don't understand, feel free to ask questions. And the last question, you have to differentiate this, okay? Differentiate this, and that's the end of it. Find the s on the t. So you see why I was giving you that concept. There is no x and y here. So if I see you writing y prime or f prime, then you are not serious. I want to see either s dot dot. S for now. Let's follow what I've given you. If you write s prime, you are wrong, because that notation applies only when the independent variable is x. I want to see this notation, the s on the t. Our independent variable is t and our dependent variable is s. So that's why I have to write the s on the t. The same techniques apply. The last question, you will solve it. It's not difficult. U and G are constants, okay? So treat them as constants, even though you are not seeing numbers there. It's not all the functions that they will give you that they will write numbers there as constant. They can give you letters and they tell you in the question that they are constant. I'm just reviewing the different type of questions that you can have. These are just some few questions that I think is necessary to this video, what I have presented here. So make sure you apply them. Watch the video several times and apply the techniques. Then we'll chat more on WhatsApp for the detailed solution. Anywhere you don't understand, feel free to ask. So that's the end of it. Thank you for your kind attention, and please share this video, and don't forget to subscribe and turn on the notification bell. Very, very important. Once you turn on the notification bell, anytime I upload videos on differential calculus or any other related content, you will be the first to be notified through a notification on your phone. Once the video is uploaded, you'll be the first to notify. Turn on this bell icon. Once it is turned on, once you click on subscribe, you will see the bell icon. You click on it, then you click on what? Personalize. Okay, you want to receive personal notification, and once you do that, you will see it will be highlighted. Okay, and also share the video, give it a thumbs up, and bye bye. See you in the next tutorial. Stop.